So the answer to your question of what's the data we're getting that's so useful, and the list you gave would simply be yes. Everything you said matters. I sometimes think of it as a three-legged stool. So our world, not always, but sometimes can be viewed as three things people are interested in. There's energy scorekeeping, as you said, so people want to know how they're using energy and whether it's being wasted, and that especially becomes true as you head towards commercial and then industrial and then mission critical like safety or military environments. That's more so even than probably in a residence. So energy scorekeeping is one. Another leg of the three-legged stool is condition-based maintenance, we say. So we're very interested, and other people are very interested in knowing when the machine's going to break, and if it broke, why. And if it's going to break, if we can let people know a little beforehand so that maintenance can be scheduled. That's the condition-based maintenance concept. That is a fantastic benefit in some environments. And the third one is human activity tracking. So sometimes what people want to know is whether the system is being used the way it's supposed to be. So on a ship, for example, if something's supposed to be run every 24 hours for some period of time, the activity tracking is we can guarantee that that actually happened by seeing the power consumption. Or I'd try it on you another way. An aircraft black box is a great example. That's basically a very complex sensing and recording system. But when you get a sensor indication, you still have to wonder from that box whether the sensing indication that you got is correct. In other words, am I seeing this piece of information because the system failed, or is it because the sensor failed? And if I do think there's a problem with the system, what is that problem? Did the engine stop, or did the wing fall off, and that's why the engine stopped, if you followed me? And of course, you can try to put that picture together from the sensing information, but the energy profile of consumption for those loads is a very helpful way to kind of back that up. In other words, if a sensor tells you a motor wasn't running, then you can be almost absolutely guaranteed that it really wasn't if you didn't see the energy consumption for it. Does that make any sense? In other words, if I don't see that motor running, no, that's the truth. Sensor was right. And if the sensor tells me it wasn't working, but I see the power draw associated with that machine, that'd make me more suspicious maybe of the sensor, if that makes any sense. So those three aspects, energy scorekeeping, condition-based maintenance, and human activity tracking, or it's how did I use the thing, are kind of the world that we're excited about using our sensor systems to explore. Well, the vampire system that I was describing to you was one piece of a much larger pile of work that we do. You actually said the word, but I'll say it again. So we're generally interested in power system monitoring. And we have a half dozen projects at least in various aspects of monitoring electric power consumption. Vampire was just one example. So it's a particular one that's mainly directed at motors and correlating vibration with power consumption. But we do a lot of other power monitoring things I won't dive into till you ask me, but as I said, a larger picture of the portfolio. We're interested in a half dozen different things about power monitoring at least, and when you're at that level in our program, in my research group, then the applications are spread across a huge field. Some could be in residences and homes. Some could be in industrial operations like refineries. Some could be in commercial buildings like a department store. And then others could be, as I said, on any mission critical system. We've been on satellites, or at least satellite test beds. We've been on ships. Navy and Coast Guard cutters. We've been on Army bases, forward operating bases to monitor power. So anything basically that uses electricity is a target for us. Probably the oldest project that came out of my doctoral thesis is working on a device we call a non-intrusive load monitor. So the non-intrusive load monitor is kind of a foundational piece of technology that we often use as a starting point or a focal point for other things we're developing as well. and we continue to develop the non-intrusive technology. The idea there is the non-intrusive load monitor is basically a box. It sits at the electric utility service entry of whatever you care about. So in a home, that would be where the meter normally is. So we would be in a similar place, maybe in your basement, to where the meter is. So it might be just on the other side of the wall outside the house. And strictly from measurements that we make at a single point, at that aggregate point where all the power flows into the building. When it works well, the non-intrusive monitor is able to disaggregate the operation of all the individual appliances inside the building. So in other words, from data from the non-intrusive load monitor, I'd be able to tell you Mr. Coffee's on, 2 light banks are on, your TV is on, and it doesn't look like the blender is on, it doesn't look like the stove is on. So I can break out the bill for you kind of continuously as it's happening. That is an exciting system for a lot of reasons. It is wonderful because it is easy to install, and we're working to make it easier to install. It is exciting because it solves a problem that existed with the other way, I would say, to get that information. So the other way people commonly get the information we're talking about is what's called submetering. So submetering would mean that's more like the IoT picture, but it's been around a long time. In submetering, you'd go around to every load of interest in a building and put something on it. And it might be wired, or it might, these days it might be wireless, but you'd put a sensor on everything, and it's a lot of work. And it's some money to put a sensor on everything you care about, and it's also a risk. You've got to worry about whether that sensor network is going to stay operating or what pieces of it might fail. With the non-intrusive monitor, the idea is that it's a very lean installation of hardware, and we hope that therefore it'll be more reliable. There's less to fail. And the price we pay for that is you have to think harder about the data you're seeing to try to break it out. But if you can do that, the lovely thing about it is it's all collated in one place. So instead of having to collect data from submeters all over the place and then figure out what the picture of what happened was, we've got that all in one box, basically, if you follow me, and can get a profile of how things operate. The non-intrusive monitor would cooperate with a lot of other things we make. So for example, a vampire unit that might be installed on a motor, if we wanted to, so we're breaking the non-intrusive idea a little bit. We're being a little more intrusive now. But the non-intrusive monitor might not be able to get some things you want. So for example, it's not easy for the non-intrusive monitor to measure vibration. If you really, really need that, what we do is enhance the non-intrusive monitor with as minimally invasive thing as we can possibly add. And that's where Vampire would come in. So it's kind of a piece in that non-intrusive world, if that makes any sense.